All right, so we've seen Kramer's rule for dealing with a system of two equations and two unknowns. We can also apply that to a system of three equations with three unknowns. Now, I'm going to tell you, it is a bit messy. But if you use the shortcut for doing determinants, it may not be so bad. So, make it very simple for you. So, just like we had before, x is going to be the determinant matrix of x over the big determinant for the matrix. Y is going to be similar kind of thing, and then z is going to be the determinant with z over the determinant itself. So your main determinant is going to be the matrix formed by just taking these coefficients and converting them into entries. So something like this. It's a lot of stuff to write with all these subscripts, but there is your main determinant. So to do your determinant for x, it's still going to be a 3 by 3. But what we're going to do is that we're going to remove that x column and replace it with these guys right here. So it becomes C1, C2, C3, and you keep everything else the same. You know what? I'm just going to make myself, let's see, I'm going to copy that. Boom. There we go. It's going to look like that. It's kind of messy, but you get the idea, right? Oh, well, what about for dy? Well, dy is going to be, yes, that's right, work smarter, not harder. If I copy this, then what I would do is that I would erase all the stuff there in the middle, because that's where y would be, and I replace that with C1, C2, C3. And I'm sure, surprising no one, for dz, I would erase all of the stuff in my z column and replace that with C1, C2, C3. So that's how we define each of these matrices, each of these determinants. So keeping that in mind, let's now take a look at an example where we use matrices to solve the system. Okay, so let's write each of our three matrices. So starting with the first one. So my big matrix D is going to have the coefficients 2, 5, -1, -3, 4, 2, -2, -3, and 5. So we'll figure out what that is. But you know what? We're going to be smart about things, so I don't have to keep rewriting. If I copy this guy right here, so copy, I'm going to paste, and we're going to make an adjustment here. So the one for x, I'm going to erase all the stuff that's in the x column. I'm going to replace it with the constants that I have in my equations. So that's going to be 31, -13, -33. And I'll find the determinant for that, and I'll divide it by the determinant of d. Well, let's see. If I do this again, this time I'm going to do this for y, which means I'm going to erase the stuff in the y column, and in its place I'm going to write the constants. So that was again 31, -13, -33. Now, we're going to do one more time here. So this is going to be the last one. This is going to be for DZ. And we're going to erase the last column and replace that with those constants, 31, negative 13, negative 33. So once we find the value for each of these four determinants, we'll have the way to build our solution set for this system of equations. Now, I'm going to try to do this quickly by copying the stuff that we have right here. So if I copy this, and I'm going to do my neat little diagonal trick, right? So I'm going to do the diagonals going down like this. All right, so that gives me, let's see, 2 times 4 times 5. So 20 times 2 is 40. 5 times 2 times negative 2 is negative 20. Negative 1 times negative 3 times negative 3 is minus 9. So altogether, that's going to be 11. But don't forget there's another part to this. You've got to do the upward diagonals. So this one, and that one. So negative 2 times 4 times negative 1 is positive 8. Negative 3 times 2 times 2 is minus 12. 5 times 5 times negative 3 is minus 75. So altogether, that's going to give me negative 79. And when I put these guys together, we have 11 minus negative 79, and that equals positive 90. All right, so we've got the big determinant D figured out. Let's go to the next one. All right, so I'm going to copy this and copy the numbers over here. And we're going to do the same trick that we were doing before. So do the diagonals going down. And that's going to give us, oh man, see the numbers are getting big, right? 4 times 5 is 20 times 31 is going to be 620. 5 times 2 times negative 33 is negative 330. Negative 1 times negative 13 times negative 3 is going to be minus 39. All right. And then altogether, that's going to give us, let's see, it's going to be 290, 251. Yes, just double checking. And then we have these diagonals. All right, so let's see, 33 times 4 times 1 is going to be 132 positive. Negative 3 times 2 times 31, so 6 times 31 is negative 186. 5 times negative 13 times 5, so 25 times 13, or negative 13. That's going to be 12, it's going to be 3, 25. Why am I trying to hurt myself? I've got a calculator. I don't know why I'm not using it. Am I afraid? Am I just trying to show off? You know what? Forget this. Let's not make careless mistakes. So 132 minus 186 minus 325. So negative 379. And when I combine these guys, so that's going to be 251. Again, I just use my calculator. I don't always say this, but you know what? Again, I don't want to make careless mistakes and then have to redo the whole video because I was trying to show off. 630. You know, I feel pretty good about that. And the reason I feel good about that is because I know that my x value is supposed to be this dx value divided by my value for the main determinant d. Okay. Next we have this guy. Oh, I grabbed too much. Don't want to grab all of that. There we go. All right, so we copy this one, and let's do our diagonals. All right, so 2 times negative 13 times 5, so that's negative 130. 31 times 2 times negative 2, 4 is minus 124. Negative 1 times negative is going to be another negative. 3 times 33 is 99. All right, so that's going to be 353. Yeah. All right. These diagonals. Let's rock these. So negative times negative is negative, and that's going to give me 26. That's going to be another negative 33 times 4. Did I already do 33 times 4 somewhere? All right, anyway, 33 times 4 is 132. So we have a negative here. It's going to be 15 times 31. Or do I do that differently? If I do that as 93 times 5, 93, 42, 465. You know what? Let's just double check that. Whoops, that is not what I want to do. Oh. Silly me. Silly me. All right. What did we say? We said 5 times 3 times 31. Yeah, 465. All right. So we have this plus the 132 plus 26 is 623. And when I do the difference here, drat, negative 623. So if I do the difference here, we end up with a positive, what is that, 270. So let's just double check that. So if I have negative 353 becomes a plus 623, 270. Okay, cool. And for this last one, copy over here, and let's get the diagonals working for us. All right. So here we go. We've got 2 times 4 times 33. Okay, so that's going to be negative 2. Whoops. That's not the color I want to use. Negative 264. Let me just double check. 33 times 4 times 2. Okay. Then we have 5 times 2. It's 10. 130. It's going to be positive 130. 31 times 9. So it's going to be a plus 279. And all of that together. So it's going to be 145. Yeah, let's just double check here. So negative 260. Whoops. 264 plus 130 plus 279. 145. All right, cool. Then we have these diagonals to do. All right, 2 times 4 times 31. So 8 times 31 is 248. That's negative 248. All right, 3 times 13 times 2. We got a positive here. 6 times 13 is 78. 33 times 15, that's going to be a plus. All right, 33 times 15. So 15, 3, 44, 95. All right. And let's combine these. So that'll give me a negative 17325. And when I do the subtraction here, 145 minus 325 is a negative 185. Not 85, 180. All right, so as I work this out, coming all the way back up here, that means that my x value, dx over d, is 630 divided by 90, so that makes that 7. Y is going to be, what do you say the dy was? 270. So 270 divided by 90 is 3. And then the z, dz divided by d, I think we had negative 180. All right, so negative 180 divided by 90 is negative 2. So for this whole system, our solution is going to be 7, 3, negative 2. But of course, don't take my word for it. Let's check this with the calculator. So go to the matrix menu and let's edit this first guy. We're going to do this as a 3 by 4. So we have 2x, 5y, minus 1z equals 31. Negative 3, 4, 2, negative 13. Negative 2, negative 3, 5, and negative 33. So remember, just typing it in doesn't give us the answer. We have to quit out of this, go to our matrix menu, and want to perform the math of reduced row echelon form of matrix A, and you see that it gives us the answer 7, 3, negative 2. So it's the same answer that we already had. Now for solving this, like if you were given no direction, you can always do the reduced row echelon form, do a Gauss-Jordan elimination. It is a process. It will work. Now, some of the numbers you come across may not be fun, and you may end up with fractions, so that's not always the best. You could try elimination, which if I were on my own, I might consider doing that. But when you've got the Cramer's rule and you've got the use of matrices, you just do it. You find each of those determinants, you do the required divisions, and you've got your answer. So I think that's kind of cool, but you got to make sure that you do your multiplication correctly and that you pay close attention to your signs. So I'm going to take a quick break, come back and do another one. So stick around.